Welcome to NYNJPA Weather Educational Videos. Okay, so for today we're going to continue on with our discussion on convection. And in this case we're going to focus on one type of convection in a winter storm. Very short video. I want to keep this simple and break this down very nicely. This is the latest NAM model guidance on February 2nd. Okay. Now you'll notice these yellow areas. This is the radar projection where you have 35 to 40 dBz. Now that is very heavy for snowfall. Okay, remember snowfall doesn't reflect as easily. So as a result, when you start to see these type of dBz levels, usually when you're into dark green, that's very heavy snow. When you start seeing this, that is either some sleet, which is likely focused over southern New Jersey, or very heavy snow. And we're going to focus on this sounding in this area right here in southeastern Pennsylvania, right over Philadelphia. Now, this is that sounding. The key aspect to really focus on is right here. I'm going to zoom in on this area. Remember what I said last week? Instability is very basically that your temperatures at the surface are warmer than the temperatures aloft, which in this case is about 950 millibars. In the winter, you don't need a large area of instability to create significant convective snowfall. It's a very sensitive atmosphere, right, when you're dealing with a winter storm. So when you start to see these indications here, this is a perfect indication of rapidly rising air supporting a low top convective snowfall threat. So this is what you want to look for. Now most times with snow soundings, you get this, which is a stable environment, moisture saturated, so you know it's precipitating, and typically what you'll see is a stable environment followed by a neutral one, where temperatures are basically almost the same as they are at the surface up to about, let's say, 950 millibars. Okay, that'd be a stable, heavy snowfall sounding. In this case, what you have is a convective sounding, where you have warmer temperatures at the surface, still below freezing. Here's your freezing line, but much colder aloft. And so this environment, what this is telling me is that we still have warmer air well above at 700 millibars and 850 millibars. We still have cold air pushing in, trying to get rid of the warm air in place. But at the lowest levels of the atmosphere, where we have that cold air really starting to advance in, we have what's basically a convective environment. And so that leads to significant lifting, because in this area right here, we have air rapidly rising. And so as a result, you get these little bands of heavy snowfall that develop. Moving forward over the next couple of weeks, we'll discuss CSI, convection, and deformation zones. And also we'll start to transition towards springtime convection, i.e. thunderstorms and severe weather, and what produces tornadoes and hail. Yes, there is a difference between hail and sleet. I'll talk about that as well. So that is a very brief educational video for today. Just wanted to keep this simple and educate you all on what to look for when you're trying to find convective snowfall.